Hello, this is W1REX, Rex Harper from QRPme, and I'm going to show you a video on putting together the new Sea Sprite transceiver board. I'm going to quickly open up the kit. Get the bags out of the way. I also have another little kit here. This is a brass set. I'm going to use these as part of the build so you can see how they work. So this is kind of a twofold video. I can use it for both of these guys. So you take the brass set, you add the little thumb screws, the nylon. One of the things in the documentation, it talks about this doesn't come with a can. So what I recommend is Dole pineapple chunks, only because I happen to love pineapple. It comes with an easy open lid, which is what you're looking for. Any can with an easy open lid will work. And if I'll put this back for a second and I'll show you. Here's one that's empty. It's empty because I'm eating pineapple. Anyway, what I've done is I put the board on the bottom of the can first. Mark it with a highlighter, a fine tip highlighter. Drill a hole in the very center of the can, and now once you've built the board, gee, it fits right on the top of the can, and you use a bolt to hold it together. The original tuna tin 2 used the can and getting it into a can without this easy open. So the easy open top leaves a little shoulder right there, and if you clean the can, you gotta watch out because that's very, very sharp and you can cut yourself pretty easy. So when I clean out the can and wash it out, I use like a paper towel, and then I put a fork in there and run it around that way. I don't want to put my finger in there and run around that. You'll cut that right open. I've done that many a time. I've been messing around with tuna fish cans for nigh under 15 years, and I've sliced my finger a few times. Anyway, the other thing that's mentioned on the instructions is there's one cut. You don't have to make it. It's better if you do. You make one cut on the trace that goes between the crystal and the 82 picofarad capacitor, and you add a 22 picofarad capacitor across those two pads, which will load the crystal and bring it very, very close to its the frequency that's written on the can, or on the can of the crystal. So I have my board. I modified it. I did it before I started building because it's a lot easier when you set it down. I actually used, if you see that, it's very, very clean. I'll bring it up. Very clean cut there. I used a Dremel with a small diamond coated round burr, and you just touch it on there and it will cut right through the copper and a little bit of the board perfectly fine. Then I scraped a little bit of the solder mask off the trace, just so in case I want to put a little solder there and make it a little easier. So first thing I want to do is let's get to building this kit. Pull the parts out of the bag. One of the things I like to do is I like to take and you sort the parts just once. You get all the big stuff out of the way, stuff that's readily identifiable. Pull that out of the pile, and you'll see how quick this is once I get the stuff stuck in the thing. Here's the bolt for the can, although I think that bolt might be a little short for a Dole's pineapple can. Here is the LM386, and throw that off the side. We got some. I'm gonna put this off to the side too. 3 electrolytics. They're all the same value. You can look at your sheet, but they're all the same value. So, and then one polypropylene or polystyrene cap. Here's a transistor. It's pretty Now, there's two different types of transistors. I don't care about them right now. I'm just going to get them out of the way. And there's a connection. There's a diode. I'll get that in there. There should be another diode in here. I'll pull that out next. This came off of a reel, so I'm going to just quickly cut the tabs off. The paper tape. You could sort of peel them off, but it leaves a sticky residue, so it's a lot easier if you just cut them. You don't need anywhere near the long traces. Now we got the chokes to deal with. You can see a resistor and a choke. The choke's a little tubbier. Same color code. It works a little bit differently, but you should be able to pull out the chokes fairly quickly. There's another one, and there should be 5 of them in the kit. So, okay. So now I'll read them. 0.22 should be another 0.22. There's a 1. There's a 10 and a 22. Now I'll go, ouch, I just stuck myself with one of those things. Okay, we'll get that out of the way. We'll go after the capacitors. Those are 104s. 104. There should be 6 of those. And let's double check that. I'll cut those off. Notice I'm holding on to them while I cut them off so they don't go flying. So 104s are pretty much the largest of the monolithics. I'll put those in back. We'll make sure we get, looks to me like there's 2 extra ones in this kit because there's supposed to be 6. So I'll add them all. Let's see. And that is a 104, but I know those are extra because there's supposed to be 6. I'll put them aside. Those will go into the junk box. I got the 047. I got the other ones, the electrolytics. So now I'm just going to line these up and put them all so that they're reading. On one side there's the temperature coefficient and particulars. On the other side there should be the numerical code. So I just go through these and make sure I set them down so they're all reading right side up. A lot easier when you do things all at once in a group. So in this case I'm not worrying about what values they are. I'm just worrying about setting them on the right side where I could read them. Then I can order them later. I got a little bent in the package. Okay, so now I know 22 is the smallest. There's a 220. 47 is next. I've worked with this circuit so often that I have these memorized. There's 100, 101. Oops, I'm sorry. We got an 82 that's supposed to be in there. Another 82. So I got 22, 47, 82, 82, 100. There's another 100. And there's a 120. There's 1200. Oops. Those are, I didn't read those properly. Those are not 104s, they're 102s. So we're going to set those off to one side a little bit where it gets a little crowded up there. I put way too many 104s. Okay, so now we got left the resistors. Whoops, there's a little connector. I'll do them back to front. I know 0 happens to be the smallest value, so I'll put that up there. We've got get them on my hands here so I can read them all. So we should have brown, black, red. That's a 1K. There should be a 222, which is a 2K. It's a 152, so that's a 1.5K. There's a 2.7K, which would be this one right here. That almost looks like red, brown, red, or red, black, red, but it's actually violet. That violet's pretty sucky. We've got two 10Ks, 10K, another 10K, a 33K, and a 47K. So there are all the parts all sorted. Now when I go to build a kit, I don't have to actually go sort and search. I know exactly where the part is. Next thing we're going to do is we're going to put some of these brass sets on. We'll just put 3 on a nice tuna can board. It's pretty easy to set up a little tripod kind of action here. And the whole idea about these guys is that when you're putting parts on, I'll set that one aside because I only need 3 on a round board, but when you put parts on and you want to turn it over as the board gets populated with all kinds of parts at different heights, these feet now will keep the board up off the bench, and it's perfectly stable, yet you can still move it around nice and easy. The thing about the little squall is you really don't even need a building manual for it, because all the parts are actually labeled on the part as opposed to an R2 and a D1. Just makes it a lot easier. So in this case I'm going to start with the power segment, and I'll put, and now because I got the feet, I don't have to worry about which order I put them in, because height makes no difference anymore. So I'm going to put that, oops, now here's the case where these guys have got little feet on them, and we don't have holes on the board for those, so I'm going to cut that off, and I'm going to cut the one off of the other one. So now I can put that on the board. In this case, those are very large holes, and it just sort of falls right out, or it hangs in there rather loosely. I've got the iron already hot. I also use brass shavings. I don't use sponges, wet sponges, or paper towels, or that thing works really dynamite. And I'll add a little bit of solder to put a glom on the end, a little dab. Then I use that dab to contact both the pad and the part. Wait a second, add a little bit to that same junction, feed it, and that's it. Now this thing drooped a little bit probably, so I'm going to go and I'm going to push some pressure on it, put some pressure on it. I'm going to reheat that one connection, make sure it's, I heard a little snap, it's now flush to the board, and I can set it down. You know, the beauty of these brass set is the fact that you know, when I'm using when I'm soldering, I want to get just that right angle, and the whole idea is this thing just swings right around, and you don't have to clamp it or reclamp it in the vise. it's very, very simple to use. So there's one nice lead. I'm going to go back and resolder this one because I only put enough to get it going. So there's that part soldered in. Flip it over. Still sets on the bench with a little bit of clearance for your feet, or your, you know, the little leftover pieces of thing. So now I got a 5818 diode, which I happen to know is this one right here. I will bend it with my, I have fingernails, so I don't really need to use a bender or a lead bender, and I usually have been building kits for so long I can get that 4/10 pretty easy. Put that space in there. Now I'm going to do two parts. I'm going to do a 0.1, which is a 104, so I'll grab one of these 104s and put that in right next to it. Seat that down nice and neat. Those are the only three parts that are in that one section, so I'll tip it over, set her down, and clean the tip, add a little solder, and get right in there. Now I want to go over there, but it's not right where I want it to be, so I'll just spin it around and I'll get right in there exactly where I want it. And there's some more parts. Put your finger on the tip when you cut it off so it doesn't go flying. There's section number 1 done. I'm just going to go right around the horn. I don't care which way they're done. This might be easier. I could later on inject a signal in there, but I'll just grab parts as I see them. So in this case, I'll put the socket in. That sits pretty nice. I'm going to put a diode in, the other diode. Now this one's a little fragile, so I might actually get some. The proper way of doing this is put your pliers where you want and use that as the stress relief, and then bend the part that's outside. So I will do that and put that guy in the bend this way. Now I got to hold the board up because this is very long leads, but I'm in the board stuffing mode, so that's okay. So in this case, I'm going to get a 1K resistor, which should be right there. 1K. I'll set that back down the other way. Next part's going to be the phone jack. These come with a little bit of a crimp in them. I generally find that to be annoying when I'm inserting the part, so I'm going to uncrimp it, stick it flat, stick it on the board. That stays put. Don't have to. Well, it's wiggling just a little bit. So I might actually get with my fingernails, just give a little bit of a bend out. What we got left over there? A 0.1. I'll go after that one too. I'm not doing all the parts there, I'm just doing a few. I'm going to double check that. 104, it's right. Okay, so clean the tip. Add a little solder and find the right spot to go after these. And I'll go right in there and I'll go after the socket. It probably might be easier just to get rid of some of this lead clutter here. Now I got unencumbered clearance to get into those. I'll get them in a nice little row. I'll just double check the mixed socket is pushed down. Hit the first one. I'll go back and double check it. I'm going to put pressure on it with my finger, re-hit that first one, and make sure it's sitting flat, and it is. So now I can just go right down the line. Biggest problem about soldering is some people who are not experienced or haven't had a lot of kit building will attempt to put way too much solder. All you have to do is have a nice even coat. It doesn't have to go all the way through the board to the other side. Too much solder is almost as bad as not enough solder. And there's most of that section now. We've still got the 3 capacitors, so I'll put that down. Put the part in. Hold it down with one finger. Spread the leads out a little bit. Get all 3 caps, make sure the orientation is right. Long lead goes to plus, short lead goes to minus. There's the 3 caps. Set her down, clean the tip, add a little dollop. Get that nice right angle and solder away. And let's see, I want to get right in here like that. Now, this is awful close to that guy. I mean, I could just twist it, move it over there. So easy. Now I'm putting a little pressure on here. I don't have a nice, really good tripod, so I'm just putting a little pressure with my finger to make sure it doesn't get tippy. And hit those 2. Cut these leads off. Then I'll move it back, so I'll make a nice tripod again. So there's 2 sections done. That's pretty simple. Get that junk out of the way. Now I'll go after the 3rd section. Easiest thing to do is generally a lot of people go after resistors, then capacitors, and build from the height, from low parts up to high parts. But with these little legs to stand off the board, it doesn't really make much difference. But I'm still set in my old ways. I'll go after the resistor first. There's 47K. The next one is a 0.1, which I know is in the back. I'll put it so it reads the same way that the orientation is on the board. Set that down as an 82. And the 82 is, I know, is right in there. I'll double check it. 82. So I'll put the 82 in next. In this case, I'm going from the center of the board out to the edge. There's an 82. Now, CBE is capacitor from base to emitter. CEG is capacitor from emitter to ground. And I happen to know on this particular circuit, those are 2 100s, which is beyond the 80, so that should be 100 right there. And double check it. I'm going to set that down. 101. 101. So now I know I got the 2 proper caps for here. 101. 101 here. Those are marked on the schematic. They're not marked on the board because if this was a 20 meter version, those 2 values would probably be 47s and not 100s. Here's a 1.5K, which should have a green on it, and there's brown, green, red. 1.5K. Now you notice I'm getting quite a few parts here without even soldering. I can do that on this thing because it's very easy to get to the right spot. I'm going to stop now, clean my tip, and I'll go right down the line. I'll add a little dollop, put that right on the part. I'll feed it a little extra solder, and it only takes a second. I happen to have a nice iron here. This is a Metcal SP200. It's a very professional iron. Probably the biggest drawback of building kits is trying to build one with an inferior iron or a very cheap soldering station. A soldering station is better than a cheap iron. You know, a better soldering station is better than a cheap one, but I wouldn't go for the bottom end of the spectrum. I'd try to go middle ground. You're going to typically use a soldering station for years and years. It's an investment. If you like building kits, I've got several of my stations around here that I've had for 15-20 years, and I paid maybe $40 or $50 for them. So, you know, splurge a little bit and buy yourself a decent station, because you're going to use it for a long time if you like this stuff. Okay, so that section is almost done. I got two more parts. I got this is another thing. This is a 6-pin SIP socket. We're going to use 3 pins for the crystal socket. I'm going to use 3 pins for a transistor socket over on the final. Another tool I have on my bench is a pair of Stanley. They don't make them anymore. I've got Stanleys, I've got Huskies, I've got ones I got at Tractor Supply. I got 4 or 5 different versions of this. It uses a utility blade as a guillotine cutter, and when you go in there, see, this thing's got little dimples between each segment because it's what they call a breakaway header. So I can actually cut that nice and clean, very straight. These are wicked sharp, so watch out. You can slice your finger right off real easy, so be very careful. Now in this case, I like to take the crystal, put it in the socket, put the socket on the board. Now I can hold on to the crystal. I'll take my solder, turn it into a sort of like a cobra stance, get my iron, bring that cobra right in, and so now it's acting as my third hand. I'll hit that just a tad. Now I know it will stay put, but it's not right. It's a little tilty. It's a little front to back. So now I can just reheat it, all the while rechecking the crystal socket. Don't quite like it yet. I'm gonna now that I like it. Square, straight, flat. It's cooled. I can pull the crystal out. Now I can go after the 2 that I didn't solder. I'm going to double check. Yeah, I like the look of the socket on there. And go back and finish it off. So there's that side. All I got now is the transistor. That's a PN2222. Which that isn't it, as a PN2222. Orientation, flat to flat, and I will do not seat it all the way down to the board. Leave it up about over 1/4 of an inch, about 1/4 of an inch or better. And that way, when you go down and hit this now with the iron, that heat doesn't climb right up in there and go right inside the transistor. You don't need to have it flat on the board. That's very, very, very bad. So here we go. There's that part. Cut those leads off. You notice I'm working pretty fast. I could probably take a break. Do another piece of pineapple. Move on to the next section, the offset. This one's pretty simple. Got an 82, which should be, that's an 82. Now in this case it's got a 0.001. We've done a little testing, and that's why we got some extra 104s in here, because that 0.001 here and over here in the keying could probably just as easily be used as a 0.1. That's a 102. That's the one I set aside. So here's a 0.1. Double checking. 104. I'm going to put a 0.1 in there instead of the 001. And the whole idea is the fact that 0.1 at 7 megahertz is an even better short than a 0.001. It's shorting that crystal to ground, and so I'm just using a better short. We got a 2.2, which is red, 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 and it's red, red, red. Red, red, red. Put it so I look at the board from the right hand side. I can read the colors right down the thing. Spread it apart a little bit. Set her down. Clean the tip. Add a little dollop of solder. Now you notice I'm doing all this without a pair of visors. Well, you don't notice because you can't see me, but I'm not wearing a pair of visors, and I'm not wearing not using a magnifying glass because I just went to the eye doctor and got a new prescription on my glasses. That helps a lot. So and there's that section. Cut the leads. I'm looking at these as I cut these off and look at them. I'm looking at them. They're very nice, very nice, good fillet. Not too much solder. It doesn't go beyond the pad. Pretty nice. So we'll continue on. Next section is the keying section. So we have a few other things. We got a 10K. I'll again go from, I'll do this low end area, then do a high thing. So we got a 10K, brown, black, orange. Brown, black, orange, 10K. Now, here's another small mistake on the silk screen. If you look at the schematic, you'll see that's a 2.7K resistor there, and this says 2R7. It's supposed to be 2K7, not 2R7. But again, it's pretty easy to spot. It'll be in the mod sheet. So there's a 2 red, violet, red, which is 2.7K. So I'll stick that in there. Okay, we need another 0.001, which is going to be converted to a 104, a 0.1. Just making a better connection to ground, better short to ground. There's that. And gee, I'm going to add the other transistor. The second transistor. This is a 3906. And again, I will just catch one leg, bend it over, and you catch the middle one, and then bend it back and catch that third one, and then seat it down so it's about 1/4 of an inch off the board, and I'm ready to solder again. Clean the tip, add a little dollop of solder, and the nice thing about these the brass set is the fact it's keeping the board about 1 inch off the bench top, and I can set my forearms, I can set the side of my hand right on the bench, and I don't have to hold this iron 6 inches up off the bench into the air, and that tires your arms out after a while. So this is very, very convenient. I'm looking at the thing, very nice connections. Set that aside. Clean house with the point with the. You notice not one of these leads went flying anywhere. They all fall right there. Clean them off. slide them to one side, and there is almost everything. We got a header, which is this guy right here. Now, if I turn that over, this thing fits very, very loose. So I'm going to actually take the I'm going to take the little jumper, and I'm going to put it on there and hold it with my finger. Use the Cobra stance again. Whoops, my Cobra fell down. Okay, there, that's good. So I hold on to that with my finger, clean the tip, add a little solder, move into that. Either one is fine, and just, it's hard to see, but just a little bit of solder. And I'm going to double check to make sure it's nice and flush. I'm going to straighten up just a tad. Then when that's cool, I can set it down and I can hit the other side. That first little solder. Once that's cool, I can go back and hit the first one and make sure that's got a nice good connection. And there it is. There's that piece. And I'm down to the other stereo jack. So we'll grab the stereo jack. Again, I'm going to straighten those two little crimpy connections. Put that together. And set that in there. I hit one, just re-look at it, make sure it looks to me like it pitched a little bit. So I'm gonna again push on it with my finger while I reheat that first section. Make sure it sits nice and flat. Wait for it to cool. Then I can get the other two pins. If you don't solder more than one pin, you can hold it in place with a finger and make sure it's aligned properly while you resolder that first. There we go. There's that section is done. Well, we're really flying now, so we're going to do the final section. That's pretty straightforward. So we might do the socket first. So we'll take the other half of the SIP socket, and I'm going to take my wonderful pliers. Be very careful, because if you move the pliers into your finger, you might actually jab it. I've done that once in about the 5 years I've owned these pliers. So what I do is I keep those steady and very carefully move the part in. I get right where that junction is, and I can separate this guy into 3 individual pins. Put that back. Get my transistor. Get these leads so that they're kind of straight. I'll put each one. I'll just manually put a pin on it. Re-straighten them again so it looks like nice straight leads on it. Then I can put that transistor in the socket. Here's the emitter, base collector, so it fits in like that. Tab on the transistor, tab on the silk screen. Hold it. Get my Cobra out. Clean the iron. Little dab of solder, and just whoops, that's got to come down from the top, not. So now I'm going to get that one spot. Look at the pins a little bit. It's kind of leaned to one side, so I'm going to reheat it. Move it a little bit one direction. I like that. That's nice and straight. Now go after the other two. Redo the first one. Transistors in. Now I'm going to just take the transistor back out because I don't really need it installed right at the moment. I'll go after the rest of those parts. We've got a 10K. There's another 10K. Brown, black, orange. You notice I hardly even had to look. I knew exactly where that part was. So that makes building the kit a lot faster. I need a 047, which is the green. 047 or 473. Put that in. I'm going to just bend the leads apart just a little bit, keep them falling out. 100 microhenry and a 22. So the 100 is there's a 22, red, red, black. It's a 220. So I'll put the 22 in. So red, red, black is 2, 2, and 0 zeros. That's how you figure that. And 100 would be brown, black, brown. So there's brown, black, brown. 1, 0, and 1, 0. So 1, 0, 0. Bend that up. Put that in. Now you can see I have a plethora of leads, but it doesn't bother me at all now because I can just swing this around and get these at just where I want to go very, very easily. 1, 2, 3, 4, 5, 6, 7, 8. That was easy. Kill these guys. Whoop, I missed one right there. I thought I had that. I spotted that when I was cutting the lead off. It wasn't a very good fillet right there. So now we got one part left, which is a 33K. Gee, it's the only resistor left, so I guess that must be it. Orange, orange, orange. Sounds like Tricks the Rabbit. Okay, now I don't really have to do that one there. Oh, I'll do it anyway. Finish that section. One of the things, if you have clean solder, you can't see that, but if you have a nice clean solder, if it doesn't have a lot of dirt on it, you don't really have to clean the tip that often. But if you have dirty solder, if you've got it laying around and you buy some junky stuff at a ham fest, you're going to have to clean your tip a lot because there'll be a lot of dirt in that roll of solder. So we've got 1, 2, 3, 4, 5 sections done. All we got to do now is the filter. So this is where you consult the schematic, and I can tell you right now, these 0.22, this is a 0.22 and a 0.22 are the front end and back end of the filter. So at FL1, and FL8. The last one here is the 1, which is brown, black, black. 1, I'm sorry, that's a 10. 1, 0, and 0 zeros after that. So that's going to go at FL5. FL5 is filter element 5 in this case. The reason I didn't mark them is because if it's a 20 meter filter, they're going to be different. So I can't really put the absolute value of that part in there. It depends on the band. You can make this for any band that a Pixie will run on. You can get the appropriate components and make the filter. That's the only, that plus that's the two capacitors between on the transistor, the CBE and the CEG. Those two capacitors will change based on what band you're using, and there's a table for that on the documentation. So that looks pretty good to me. We'll cut those off. Okay, we're getting close. Look at that. Now FL2 and 3 and FL, this is like a symmetric thing, so the values are the same. In this case, we got a 1200 picofarad, 122. Now, I couldn't get those. Sometimes it's hard to get a particular value in a style. So in this case, both of these 1200s are 0.1 spacing, yet the board is 0.2. So all you got to do is take your needle nose, spread them out at a 90 degree like that, and then just go out just a little bit and bend them back up, and voila, you got 0.2 spacing. So I'll pop that right in. It'll take you a little experience to do that, but now here I'm going to pop that off for a second, just get it out of the way so I can work right here. And there's 120. I'm going to bend the leads a little bit because this is I made this one. I'm going to make sure that's okay. I'll put this guy over here at the output of the filter. That's close enough to a tripod for what I'm doing right now. Okay, so I got another 1200 I have to make into a 0.2 spacing. So spread it out and go out about another 1/2 and I got another 1200, so I'll put that at 2. They go the 2 and 3. Everything's in parallel here on the front end and the back end, so it doesn't really make any difference which side you put it in as long as you're consistent. So as long as you give them the right place. So I'll solder those in place. And in this case, I'm not putting a lot of parts in because these were like hand bent and they're kind of a little on the loose side, so I'm just going to get them in there. Okay, our inductors are all done. Everything's good. We'll cut those off. Okay, this is where we need the 102s. So we actually need 2200 picofarads. So we're using a 1200 and a 1000 in parallel. I'm going to double check, make sure these are right. 102. Because 2200 is not a standard value, so you got to make it with 2 caps. There's the 102. So now we have, and the last filter element, FL4, is the 47. Again, we've got this 47. We've got a 1/10 inch spacing part, so we have to bend it. Okay, that looks good. Right above it is a 0.1, which is the last of the 104s. 104. Put that guy in. And we're ready to do some soldering. Clean the tip. 1, 2, 3. I'm going to swing it around and get in at a different angle. There's, whoops, did I get that other one? Yep. Okay, cut those off. Looks good. I'm down to this connector. I already chopped the feet off, so I'll put that on. See, that falls out, so in this case I'm just going to hold it with my finger. Get my Cobra out. Clean the tip. Add a dollop. Move that Cobra in there and just... all you got to do is tack it. Come on. Double check that it's nice and flat. It's cool, so I can go after the second one. If you ever went after the first one, it would fall out again. So I'll go after the second one. Get that done. Then go back to the first one after that's cooled, and it will stay in place. And clean that guy up. Everything's looking good. I've got to add this mod. This is the 22 picofarad capacitor on the mod, so I'm gonna actually, I'll put a little solder on that trace and the other part of it, and I'm going to just add a little solder to the ends of the leads. I don't want it a lot, I just want it tinned. And there's the cut. In this case, it might be. Let me get rid of one. Let me get rid of one of my hands here and clean this. This pair of pliers became magnetized, so every time I set it down, it picks up all that durber. So I'm just gonna hold that with the pliers, and nope, not yet. I'm going to add some little feet to it. It doesn't have to have much, just a little bit of a turn. And now I can set that right in there on those two. Those little feet are hooking it. I'm pulling it this way with the pliers, and there's that mod. So the mod's been made. I'm inspecting this board, and I see this pin right here, right there. I think I'm a little shy on solder, so I'm just going to go in and just add a little bit of a solder to it, and that's it. I didn't like that one. Now I'm looking at it carefully. I think everything looks good. Put the iron up. These guys are done. I can put I'm going to squeeze these together just a little bit so that they're kind of more straight, and I can set that in there. Set one side in and sort of rock it a little bit and get the other side in, push it in. Crystal would go in here like that. Transistor will go in the socket. And there is a little squall. I'm sorry, this is not a little squall, this is a Sea Sprite. There's a Sea Sprite ready to go. One of the things I didn't show was the fact that I also include a 2-pin screw terminal that will fit in the same socket as this. RCA for people who like to bring in power at a regular wires. I have a complete tuna can station, and I have power leads that are RCA, so I leave them as RCA. So the other thing that you have to do is, if you don't heat sink this transistor, you will burn it up. So there's a heat sink provided. It's best to put the heat sink on the board and put the transistor into it like that, and now you can put it back into the board. And there is a Sea Sprite ready to go. And that's it. Oh, put it in the tuna fish can with the pineapple chunk can. Use the board, and I think I accidentally included. I used 1.5 inch. That needs to be a 2 inch for doles. This is a number 632 by 2 inch. I have to go get one. Sorry about that dead space. Here's a 2 inch. Goes down in there. I'm fishing around. I'm trying to get it nice and flat on the board, so when I put this on, I can actually see it out the bottom. And there it is. Add a little nut to it. You can use I will have a nice new label for that on the website that you can print off on your printer, and you can just take the pineapple can and peel that label off. I'm going to bring it around so it's nice. Yeah, so there's a nice clean front, but I can also put a label right back on the can. And there it is, a sea squall ready to play. Thank you very much for watching. Hope you enjoyed it.